Hi there, this is Mar Haddad here again. We have to continue the discussion of what we have started, and now we are going to speak about the frequency and the wavelengths. So as a review, we have said that we have the electromagnetic spectrum, and we said that the 802.11, which is the Wi-Fi, works on a specific place of the electromagnetic spectrum. And also we spoke about the wave, which is type of transmission that we use to send some data from point A to point B. And we also spoke about the two different types of waves that we may have. And I explained all those in the last lecture. Let's continue now speaking about the frequency. So the frequency is the rate that a wave has been repeated. So what does it mean here? Now, if you know that everything in the world has some measurement, so we have to measure the wave, how many times it has been repeated to be able to reach to the destination. So in this case, we use the frequency. Now, remember that the frequency, when it is higher, the wave cycles are more often, while if the frequency is low, then the cycle is less often. So if we take those two pictures, you can see this is a low frequency. So say that this is, for example, if we talk about the wireless, this is 2.4 gigahertz. And this is the 5 gigahertz, which is higher frequency. So on the 2.4 gigahertz, you can see that because the frequency is lower, then you can see that the wave cycle are less often than the 5 gigahertz. So the 5 gigahertz, you can see, like if you have here this complete cycle, all right? So over here, you may have on the 5 gigahertz almost 2 times to reach to that point. And this will cause issues because when you have a frequency which is very high, then it will not be able anymore to pass through a lot of mediums like wall or glasses or whatever. It will be more difficult than when it is on low frequency. Then it can penetrate more those mediums, and then the signal can be received further. But the other problem is that when you use the 2.4 gigahertz, you have less bandwidth than when you use the 5 gigahertz, where you have more bandwidth to use. So those things you have to take into consideration. Now, the other thing that are talking about here is the units of the frequency, which is Hertz, based on Heinrich Hertz. So this is the name of the person who was a physicist living from 1857 to 1894. And he provided the existence of the electromagnetic waves. So normally we don't measure with the hertz, we measure with the gigahertz. You know, you have megahertz and gigahertz, so it's like, for example, you have meter and you have kilometer. So that's something, on the wireless we normally use the gigahertz. Now in WLAN we normally use 2.4 and 5 gigahertz. Also, we can see the 6 gigahertz nowadays, which is 802.11ax. And also we see the 60 gigahertz mostly for outdoor point-to-point. So those normally are the frequencies that are used. Now, if we think about the 60 gigahertz, do you think that if we would use point-to-point with 60 gigahertz, this will go very far, or will be the distance will be very short? If you think of it, 60 gigahertz is a very high frequency, and we said the higher the frequencies, the more waves that we have, and then it doesn't penetrate very easy into the medium. Even if you don't have anything, just the air, then that's also a type of medium which can attenuate our signal. So meaning that we can go on 60 gigahertz more than maybe 1 or 2 kilometers as maximum, even though that you have really a lot of bandwidth then, but yeah, it doesn't go very far. And that's why if you are in a country where you have a lot of rain and the weather is very bad. So using 60 gigahertz is not a good idea. But if you are in a country where the weather is good, because the weather also affect and the water or the rain also affect the signal while traveling. But if you are in a country where it's mostly sunny, then yeah, using 60 gigahertz would be a good idea. Now, we spoke about the frequency. The last part of this lecture, we are going to speak about the wavelengths. So the wavelength is defined as the distance required to complete a full cycle. So you can see this is one cycle, okay, and this one cycle, this is called a wavelength. So when it goes up and then down and then to here, this is one wavelength. So this is a second wavelength over here. Now, the higher the frequency, as we said, the shorter the wavelength. Remember, when you go with the frequency high, the wavelength becomes shorter. Of course, you can have more bandwidth, as I said, but it doesn't go very far. Remember what I spoke to you about the 2.4 and 5 gigahertz example? So just keep that in mind. And here they give you a better explanation. When you use the 2.4 gigahertz radio frequency wave, is about 12.5 centimeter, or if you are in the United States, you use the inch, so it's like 4.92 inches. While the 5 gigahertz, so the wave, it is 6 centimeters, so you can see it's half of it, and an inch is 2.36 inch. So you can see that the wave on the 2.4 is much bigger. That's why it can go much further than the 5 gigahertz. So you need almost double of the 5 gigahertz to reach to the wave of the 2.4 gigahertz. So that's a good example to show you that if you go to the frequency lower than the wave cycle, it is longer than the one which is on the high frequency, because then it is much shorter. So that's why the 2.4 gigahertz frequency can reach further than the 5 gigahertz frequency. So those are things that you need to know in the exam to be able, in case you get questions about them, to be able to answer them. So this is all what I wanted to show you in this lecture. So we spoke about the frequency and the wavelengths. So remember that you always have to look what frequency you are going to use based on what scenario. So for example, you can't use the 60 gigahertz if you are in somewhere, I don't know, when it is too raining. So that's something you shouldn't do it. You better use a lower frequency which can pass through the rain. So this is all what I wanted to show you in this lecture. I hope it was informative for you, and I will see you in the upcoming lecture.